have a look. The box plot question we're going to go over is to do with outliers and finding the interquartile range and the 5-figure summary. So the first thing you need to do for this is to open your calculator. We are going to go onto the main screen and we are going to have a look at the Stat button. Once you press the Stat button, you are going to be able to edit a particular list. So we're going to press Edit. Now, there are a couple of options. You can either put it into list 2, or if you want to put it into list 1, we need to clear the data in list 1. So to do this, you need to go back to the Stat menu and we need to click Clear List, which is number 4. We're going to clear list 1, which is the blue above the number 1 button. So press second 1, press Enter, and it is done. So now we're going to go back to the Stat, we're going to press Edit, and I'm going to type in the numbers one by one. So we have to type in a whole 25 numbers for this question. So let's go now. First number we're going to type in is going to be 12, then 5, then 13, etc, etc. Let's go. You can see the way I've typed them in has not been correct, so I need to clear them and have a go at them again. So let's type in 5. And you can see my 2 ones should actually be 14. And because there are 25 numbers, this should be on number 26. Let's have a quick scan through just to make sure they all look correct. Let's read them out and cross-reference with the list. And I'd recommend you do this. 12, 5, 13. This should be 13. 16, 8, 10. 12, 18, 9, 11, 14, 14. 22, 9, 10, 7, 9, 11, 13, 7, 10, 6, 13, 3, 8. All correct. Excellent. Now, to find the median, lower quartile and upper quartile, you can either do this by hand, and a method of doing this by hand would be to order the data and then to find halfway through, which is the median, a quarter way through, which is quartile 1, and 3/4 of the way through, which is quartile 3. This means the first few bits of data represents 25% of the numbers, the second bit, or the second quarter, is another 25%, the third quarter is another 25%, and the last quarter is the final 25%. The easiest way to do this is to go into the Stat menu and we're going to go into Calculate. And because we're dealing with just one variable, we're going to press number 1. We want it to analyse list 1. We want to analyse list 1 as well. And we are going to press Calculate. Here we go. We've got the minimum, which is the smallest number, quartile 1. And if you carry on scrolling down, you are going to find all the 5-figure summary. So to draw a box plot, if you were to draw a sketch, you wouldn't have to draw it accurately. All you'd have to do is draw 2 lines at the end, a box in the middle, a line going through the box, and then once we've done that, a line going through the central part. And then we'd say the smallest number, or the line on the far left, would represent the minimum. This would be quartile 1, line 1. The middle line in the middle of the box would be line 2, would be 12, which is the median. Line 3 would be quartile 3, which is 14, and the maximum would be 22. Now remember, the interquartile range is the distance, or the distance between quartile 3 and quartile 1, which is the size of the box. So for the interquartile range, you have to understand you get the 14, and then with the 14, you're going to minus 9. So for this particular question, our interquartile range is going to be 14 minus 9. Let's talk about the other bits of information. So we've talked about the median, lower quartile, upper quartile, etc. So that's going to be 9, 12 and 14 for question A. The interquartile range, as already discussed, is going to be the distance from the quartile 3 to the quartile 1, which is 14 minus 9, which is going to be 5. And the box plot, we've already drawn a box plot. So that's really quite straightforward. But what's not so straightforward is drawing and identifying the outliers. So let's talk about what the outliers are. Now the outliers need this formula. So basically, the way the outliers work is to talk about whether data suits something in particular, whether the data you're studying is that out of the norm or not. So going to a PowerPoint, we can talk about this step by step. Let's have a look at this data. Now, let's say we have a person. The person's going to be represented by a smiley face. And let's say this person has an age of 30. Now, this is a bit of a side note, which is not directly linked to the topic, but may help you remembering the outlier idea. Let's say this person's 30 years old. Now, there's an unwritten rule, which you'll be able to find on multiple websites, that says if this person was to date somebody, what you would do is you would add half their age and then minus 7. So let's say half their age is 15, so 30 plus 15 minus 7. So that's the same as adding 8 to 30. So we're going to say that the absolute maximum age this person can date, according to this rule, is going to be 38. Now, similarly, the rule to do with the minimum age is minusing half their age, but plusing 7. So very similar methodology, apart from you're switching the signs of these two numbers. So this time we are going to be subtracting 8. So we're going to say the minimum age is 22. So we could say that if we had a list of potential suitors for this person, let's say we've got someone who's 27, 45, 63, 22, 32. Out of this list, we would have outliers. So there would be ages which would not suit the lower boundary and the upper boundary. So we're going to call this our lower boundary and we're going to call this our upper boundary. So any number which is smaller than 22 is going to be an outlier, and any number which is bigger than 38 is going to be an outlier. So we're going to say that the 45 and the 63 are definitely outliers. So for this set of data, which represent different people's ages, we are going to have 2 outliers. Now, we're going to apply that idea to this problem, but the formulas are going to be different. But as you can see, we've got the plus and we've got the minus, a bit like we switched around the signs here. So let's take, in this instance, our data. These formulas need to be memorised. So the upper quartile is the same as quartile 3. So remember, quartile 3 is the upper quartile. That also needs to be memorised in the exam. We need to take 14 and we need to add 1.5 times the interquartile range. Now, we already calculated the interquartile range as 5. So all you need to do is put this into a calculator. We are going to get, I believe, 21.5. Now, if we are going to study the next part of the equation, we are going to now have a look at the lower boundary. So this is a bit like the dating. So we're going to say that the maximum number for this set of data in which we'd consider any data beyond that abnormal is going to be 21.5. Let's now repeat this process, but for the lower boundary. So we are going to take the same calculation as we did before, but rather than adding, this time we are going to subtract. So we are going to get 14 minus 7.5, so our answer is going to be 6.5. So going back to the question then, our data we were talking about is to do with this question here. We had 25 bits of data. Now this question you do need to do manually, so you need to understand how it works. You cannot do it easily on the calculator. So what you have to do is you have to study these numbers. Imagine as if they're in terms of dating. So we could take the median as the person who's dating. The median in this instance is 12, although that wouldn't quite work for this instance because that would be a bit of a strange question. But let's say the middle number is 12. What is going to be a number which is really outside of the realms of what we consider normal? We're going to consider anything below 6.5 as abnormal, anything above 21.5 as abnormal. So let's study the list. Studying the list then, what we're going to do is we're going to tick anything which is smaller than 6.5 or bigger than 21.5. We're going to have 5, that's certainly smaller, and then anything that's bigger, 22, I think that's about it to be honest, and the 3, and of course the 6. So we are going to have 4 outliers for this question, and you could list them as 5, 22, 6 and 3. And going back to the question, we can see, let's see if we got this correct. Find the lower and upper boundaries and hence identify any outliers. For this particular question, we would just state, as I suspected, the lower boundary is going to be 6.5 and the upper boundary is 21.5, therefore the outliers are 5, 22, 6 and 3. Easy peasy lemon squeezy. Finally, we are going to have a look at a different kind of question. Our different kind of question is when we've got to draw a box plot, but it's in a frequency table, but this is not too difficult. So there are a couple of ways of doing this, but the easiest way is to go back to the start menu. We're going to clear the list, so go to number 4, and we want to clear list 1. So we're going to press second, and we're going to press number 1, and then we're going to press enter. We're going to go back to the start menu, and we are going to click edit. We're going to enter the information in. This is 33 through to 40, so this is quite easy to type in accurately. Let's see if I can do it correct this time. The good thing about these calculators you can get on your computer is that you can type the numbers in using your keypad if you're not going too quickly. 15713 for the list 2, 1312801. And of course, what we are expecting for this is there is going to be an equal number of numbers in list 1 to list 2. If you've got different numbers, you have gone wrong for this question. So let's actually look at the question. Randy counts the number of bolts, and in this bolt question, he has several boxes and tabulates data as follows. So number of bolts, frequency. So we're going to say in different boxes, we've got loads of boxes, and the number of boxes we have all together is going to be all these numbers added together. So it's going to be about 26, 38, 38, 47 boxes, and each of these boxes you have different numbers of bolts. So in one box we have 33, 5 boxes we have 34, 7 boxes we have 35. Now for this, you have to go back onto the start menu, and to work out the box plot, we are going to be dealing with a one variable statistic, because we're still only dealing with one variable. The variable is the number of bolts. This is where people get a little bit confused. Sometimes they press number 2. So press number 1. We're going to say the list is in list 1, but the frequency of the list is going to be in list 2. So this time, because it's in a table, we have to change this to list 2. Press enter, calculate, and here is our information. Let's have a look to see if this looks valid. The smallest is 33, the maximum is 40. That links with the table, excellent. The median is 36. Now you might think it might be 37, but the way these numbers are distributed means the median is actually 36. Quartile 3 is 37, quartile 1 is 35. So this is really quite a straightforward question. Now, last but not least, we are going to discuss the standard deviation, because a question in the exam might ask you to find the standard deviation. Now, the standard deviation for this question is going to be this one here, which is 1.406188.225. So just remember, it is the fifth one down. And the standard deviation basically says how much does each of the data vary from the mean. So we're going to say our mean is 36.2555. So let me draw a quick diagram to explain what I mean by this. Let's say we have a graph, and we're going to say we have lots of different values like this. And effectively what the standard deviation does is talks about and measures using a certain variable how much each of these values vary from the mean of 36. So the closer the number of bolts are together, so the closer and more similar these numbers are, the smaller the standard deviation gets. So if we were to have a list where all the numbers were the same, what do you think the standard deviation would be? Pause the video and have a think. So I'm going to show you an example now. So if we have all the numbers the same and we wanted to analyse these, and we wanted to go on to one variable statistic, and we're going to put in this time list 3 for both of them because it's not a frequency table, we would see here the standard deviation is going to be 0. And this is because the values don't vary at all. So the standard deviation is simply going to be 0.